Here in the first chapter, we are going to start with the concept motion in a straight line. This is our first chapter. And the first thing what we are discussing, this one is about what is the difference between distance and displacement. Very basic concept. The distance is what? The difference from one point to another point by any route. For example, in this given example, you can see this is point A and this is point B, let's suppose. If I ask that what is the distance from point A to B, so the distance is this green line. It will go straight and then he take U-turn and come back and reaches here. So this complete will be what? This complete will be its distance. This
Sir?
Yeah.
Before you continue, I just want to make sure that our book's first chapter is velocity and acceleration.
Yeah, it will also come there. It is in the same one. Right?
Okay, sir.
From distance, we will start with the speed. From the displacement, we will move on towards velocity. Okay?
Okay.
So this one is the distance and displacement. And displacement is what? This blue color line from here to there. This one is what? Displacement. You can see the displacement is very small and distance, wherever it will move, this one is called distance of this object. These concepts, first of all, distance and displacement.
Okay.
And after, when we move on in this one, we got that concept about speed and velocity. The same thing is here in speed and velocity. Whenever you are calculating that distance over time, distance over time, this is called what? This is called speed.
Speed, yeah.
Speed is equal to distance over time.
Distance
and
over
be
time.
Careful in this case, wherever you are going, it is not matter, it is not concern wherever you are moving. In case of what? In case of speed, in any direction, in any format you are moving, this is what? This is what? Speed. And whenever you are going in a specific direction, in a particular direction, so this will call velocity. So velocity is also same. Velocity is equal to displacement over time. That what is your displacement and divide with time. So this is the basic difference between speed and velocity. Right. You can take the screenshot along with this, fill all of this thing what I'm writing. So you can share in the group. And if the message, yes sir, you are lagging a lot. Okay, no problem. I will share the video as well along with you. If you will miss something, you can note down from there. So this will be what? The difference between speed and velocity. That how much distance will cover in what time. Here, when we talk about distance time graph and speed time graph are two of the very famous graph are there. And how you can find with the distance time graph, in this one, you have distance on y-axis and time on x-axis. And with the help of this distance time graph, what you can calculate? You can calculate the speed. If this line is more steeper, then it will be more speed. For example, if the line is like this, I call this one L1. So it means speed is less. If I talk about this L2, it means speed is high. If I talk about a line like this, so speed is more. And how you can find? By calculation, you can take any of the point like this, at this point. How you can find speed? Distance over time. What is the distance? 1000. And what 1, is the time? 300. You can see, if you read this value from here and there, you will find 300 and 1000. So tell me, what is the speed of line 1? Speed of line 1.
So it's 3.33 something.
3.33, 3.33 something.
It's reoccurring.
And what about L2? Take any point here, like this one. Now this time, what the distance is, or distance is 3000 and speed is, time is remain 300. But the distance is 3000. Yeah.
So it's 10.
10, sir.
It's 10 as per the unit meter per second.
Yes.
Right. What about this L1? If I take this point, because you can take any of the point on this line.
Yes.
What is the speed of this? This one is L3 basically. L3.
Sir, 23.3.
So 23.3 reoccurring.
So what you discover from here, that as much as the line is steeper, as much as the speed is more. Got this point?
Yes, I understood.
So this one is the concept
Yes, sir.
about distance time graph. You can also take the picture of this. After that, the next thing is average speed. What is average speed? Average speed means total distance over total time. Wherever the object is moving, it go at one side and then go on the other city and go to the other third place and then go to the other place. So add all the distance. This one is the start point and this one is the ending point. So let's suppose from this to point A, then point B, then point C, and then ending point. So starting till ending, it covers the following distances like 5, 2, 3, 4. How much total distance will be? All this one are kilometers.
What's it?
What is the total distance is covered? From A to B, 5 kilometers. Start to A to B is 2 kilometers, B to C is 3 kilometers,
So
C to
14.
D is 4 kilometers.
So 14 kilometers.
14 kilometers. And let's suppose it take 2 hours to complete this.
So 14 divided by 2.
Yes. So what will be the
That'll be
average
7.
speed?
7.
7. You add all the distances. All the distance is 14 and all the time is 2 hours. Whenever separate time will be given, you will add all the times and then you will put it down. So like this, you can find average speed there. Is this unclear?
Yes,
Yes,
sir.
sir.
Similarly, if we give you the displacement, so average velocity is also total displacement over total time. Whatever the displacement is there, you will add all the displacement and divide with time. So you will get that what will be the average velocity. We will solve the question also for this. Now, another very important thing here, velocity at an instant. I wish that then you read this point. First
The
paragraph.
position time graph for a marble thrown straight up into the air at 5.
5 meters
So
per
what's the
second.
unit?
Right.
Meters per second.
Size.
No, meter square. Yeah.
Yes, sir.
Now
Meter
it's
per
okay.
second is inverse.
Yes, 5 meter per second.
So we are supposed to say inverse, right?
Yes.
No.
It is also
Yeah.
called meter per second or meter second inverse. Both are the same statement.
Okay, sir. It's curved because the velocity is continually changing.
See, in this case, you can see you don't have a straight line, just like the previous one. If you look at this red color curve, they don't have a straight line. So what you will do in this case, you have to find specifically that what is this point is. Okay, wait for a minute. Yes, guys, back. Yeah, so for this one, you have a specific point here. At this instant, you can find that what will be the velocity. How you can find the velocity of this at this specific point, at this particular point? Because in this curve, you can see this one is continuously changing. You cannot find at a specific point. You cannot find a straight line like this. So you take one of the point on that line. In this case, you will find the approximate answer, not the accurate one. Okay, what you will do in this case?
Okay.
You will find approximate answer. So you will consider that from this point, there is a tangent. You know what is the tangent?
Yes, so when the line touches the curve or
Yes, this thing we are
yeah.
discussing in pure mathematics also. When a tangent touches a curve like this, this one is a tangent. So what we will do, we will consider one of the tangent at that point, just like at this blue point, and then we will find what is the gradient of this tangent. Remember the gradient? Here I will show you this. This one here. This line,
Yeah.
we assume that as a tangent of this one. I make more longer line like this. Right. So we assume that this line is the tangent. And from this tangent, we will find the gradient. We take any of the 2 points on this line, and then we apply the gradient formula. What is the gradient formula when you have 2 points? Let's suppose this one is x1, y1. This one is x2, y2. Yes. What is the formula of gradient? M.
Uh, so x1
y2
plus
minus y1
oh,
over x2 minus x1. Right?
okay, sir.
y2 minus y1 over x2 minus x1. If you apply this formula, you will find the gradient of this line. It means you will find the speed of this line. Gradient means what? Speed. You can write in position time graph or distance time graph, both are the same one. The gradient will tell you the speed of particle
So you're speaking the whole time.
at a specific point. If you understand, you can write. After that, I'll share this one.
So we did not hear anything.
Okay, I will share with you. So I repeat this one, what you have to write, that you can find the speed of a particle at a specific point with the help of the gradient of the line at that point. You will draw one of the tangent, you will find the gradient of this tangent, and it will tell you the speed of this object. Also, you can apply the formula of the gradient for rise over run. This formula also you can apply, rise over run. With the help of this, you can find that what is the gradient of this line. Once you will find the gradient, it means this one is equal to speed of that particle. So here is the concept of the velocity at an instant. Instant means what? Instant means very quickly, in a short period of time. When you will find, this one will be what? This one means a very short instance. So in Urdu we can say एक लम्हे में जो हम velocity निकाल लें, this will be the single instance of that one. Now in this one, another thing, अगर हम बात करें velocity की, you can see that from this line, what was the velocity? The velocity was 5. After that, what? It was decreasing. After 0.5 seconds, the velocity was 0, according to the graph. And then after that one, it is going to the negative side. Till here, you can see it is -6. How it is possible that velocity is -6? For example, कि अगर आप कोई कार चला रहे हो, तो आप कार की स्पीड कम करते करते कितनी कर सकते हो? 0. लेकिन 0 से भी नेगेटिव स्पीड में जा सकती है कार. नेगेटिव स्पीड में जा सकती है. नेगेटिव स्पीड में जाने का क्या मतलब है कार का? Yes, can anyone guess?
Sir, the thing is, we can't understand anything, so what are you supposed to guess?
No, I am asking that if I say that car is moving with the velocity of 5, you can reduce the velocity of the car. Continuously, the velocity will going to be decrease. So at one instance, you will find that the velocity will be 0. इस ग्राफ में दिया हुआ है कि velocity -6. So how it is possible that velocity is -6? Is it possible कि velocity negative चली जाए? Velocity negative कैसे जा सकती है? यानी आपकी स्पीड जो चल रही है, क्या ऐसा हो सकता है कि आपकी स्पीड नेगेटिव चली जाए? Yes. अब आवाज बेहतर हुई? मैंने नेटवर्क
yes, sir.
दूसरे पे स्विच किया नेटवर्क. तो नेगेटिव वेलोसिटी का मतलब ये है कि अगर नेगेटिव वेलोसिटी है तो इसका मतलब है कि डायरेक्शन चेंज हो गई है. क्या मतलब है इसका? डायरेक्शन चेंज हो गई है. यानी अगर -6 है ना, इसका मतलब है आप कार को रिवर्स में लेके जा रहे हो, पीछे लेके जा रहे हो. इट मींस दिस वन इज द नेगेटिव वेलोसिटी, राइट? तो वेलोसिटी नेगेटिव हो सकती है, लेकिन डिस्प्लेसमेंट नेगेटिव नहीं हो सकता. अब ये 10 मिनट बाद जैसे मीटिंग खत्म हो जाएगी तो रिज्वाइन कर लेना इसमें. तो ये एक और कॉन्सेप्ट है नेगेटिव वेलोसिटी का, इसको भी ध्यान में रखना. Now from here the second exercise he gives some of the questions there. I will share these questions also and from your book also. इसमें इसने कुछ questions किए हैं, so try to give the answer. If you can see this one, read question number 2. उमेश, पहले में तो उसने ड्रॉ करने के लिए बोला, तो सेकंड के अंदर ही है. Yes, Umesh, read question number 2.
The distance time graph shows the relation between the world and the time for a person who leaves home at 9 a.m., walks to a bus stop and catches a bus into a town. And describe what is happening during time from
A to B. A से B के दरमियान इसको कैसे डिफाइन करेंगे इस मूवमेंट को?
Sir, it's steady.
Yes, because this one is distance time graph. And distance time graph, whenever you have a straight line, it means this object, this man was stationary condition. He was standing condition. He was not walking.
Yes.
Right? 2. Amid, read.
The section BC is much steeper than OA. What does this tell you about the motion?
Yes, BC is more steeper. As I told you, you have calculated also different speeds. So what this steepness will tell you? क्या पता चल रहा है इसकी steepness से? BC is more steeper than OA. OA line is this, and
Yeah.
BC line is this. Yes, what do you say about
Sir,
BC line?
so the motion of the bus was faster than OA.
Yes, BC shows that the speed is much faster than OA. Right?
Right, sir.
Okay. Here in this one, कुछ ग्राफ्स वगैरह बनाने हैं, ये चीजें इसके ऊपर ड्रॉ करनी है, ये एक्सरसाइज क्वेश्चन हम तुम्हारी बुक में से ही कंप्लीट कर लेंगे. नेक्स्ट टॉपिक की तरफ आते हैं. दिस वन इज एक्सेलरेशन. Acceleration is what? Yes, Dhyan, do you have physics concept acceleration?
So acceleration is one when gain speed.
Whenever there is a change in speed, whenever it is increased to decrease or decrease to increase, this is called what? Acceleration. So how you can define the acceleration? You can define the acceleration change in velocity, change in speed with respect to time. So here you have the formula for the acceleration as well. That average acceleration is what? That change in velocity, how much velocity is going to change and how much time it is taking. This is what?
Right.
This is acceleration. Right? आपकी गाड़ी बड़ी तेजी से जा रही थी, आपने देखा आगे सिग्नल बंद है, आपने ब्रेक पे पाँव रख दिया, आहिस्ते आहिस्ते आपकी कार की स्पीड कम होना शुरू हो गई. It means this is what? Negative acceleration. And negative acceleration is also called retardation. Similarly, आपने देखा कि सिग्नल खुला, उसके बाद गाड़ी चलना शुरू हुई, रोड बिल्कुल ओपन था, आपने स्पीड पे पाँव दबा दिया, कार की स्पीड एकदम से तेज हो गई. Now you are going very faster. So it means this is what? You are accelerating your car. You are increasing the speed of your car. Right? Right? Yes, connect back. Yes, are you listening? Yes, are you listening now? Yes, connect back.
What's it?
Connected. I think it was disconnected there.
Yes, connected now.
Can you see the screen?
Yes.
Yes, sir.
Okay, so I start with the same thing what I was describing, that acceleration can be found with the help of velocity time graph. Can find the acceleration with the help of velocity time graph. Remember, speed can be calculated with the help of distance time graph or position time graph, and acceleration can be calculated with the help of velocity time graph. And same, with the help of velocity time graph, you will find the gradient. Let's suppose here I am sharing one of the graph. One object is start from point A till B, and from B to C, and then C to D. What this graph shows? A to B was what? In the velocity time graph or speed time graph. You can see this one is not the distance
Sir,
of
it was moving.
huh?
It was moving.
It is moving and it is accelerating. Its speed is increased from A to B. Its speed is increased. What was
Right.
the speed at point A?
Right.
It was 4.
It
Less
was
than 5 was there. At point B, if you will see what is its speed? 10.
it's 10.
So from A to B, the speed was increasing. Definitely, when
Right.
the speed was increasing, it means it is accelerate. So you can say from A to B, from A to B, it's accelerate. And how much accelerate? How you can find? With the help of the gradient of this line.
Yes, sir.
And you know how you can find the gradient? By all these methods you can apply. Here I am using, okay, rise over run method from here to there. I draw this line here, draw the line at this side. Yep. What is rise from here to there? This one is 6. What is run from here to there? 5.
4.
This one is also 6. No, this one is 5. So this point is 6.
Oh, okay, you're talking about that.
Right?
Okay,
I'm
sir.
sorry, sir.
I increase the size of this one so you can clearly see.
Yeah.
Rise is also 6. Run is also 6. So the gradient m is equal to 6 over 6. 6 over 6
Y2
is
minus
1.
4. Oh, right.
So 1 meter per second square. This one is the acceleration. So remember that whenever velocity time graph or speed time graph is given, how you can find the acceleration? You can find the acceleration with the help of the gradient of the line. Okay. Now, what about B to C? How you explain the motion of the object from B to C? What was going to be happening?
Sir, it's moving but not accelerating.
It is
Stationary,
It,
sir. B to C,
oh,
no?
yeah. No, it's moving but not accelerating.
yes. In speed time graph, Dhyan, this one is not a stationary condition. If it is a
Oh, sir.
straight line, it is moving with constant speed or constant velocity.
Right.
Or you can say
Okay, sir.
no acceleration. No acceleration. What was the speed at point B? When the object was at point B, what was